Now we're looking at variations of the angle is half the arc. Remember, if the intersection of the two lines is on the circle, then the angle is half the arc. If the intersection of the two lines, in this case two chords, is inside the circle, it's going to be the angle here is half the sum of these two arcs. So basically what we're saying is the measure of angle x is equal to 1/2 the measure of arc JM plus the measure of arc LK. So those two arcs added together and divided by 2 will give us this angle right here. So in this case it's 1/2 130 plus 156. This gives me half of 286, and half of that is 143. So this angle right here, try again. This angle right here, angle X, this is 143 degrees. Okay? Again, these two chords intersect inside the circle, therefore using this theorem we add the two arcs that the angle intercepts, which is either one of these, and we divide by 2. So adding and dividing by 2 we get 143. Now if the intersection is outside the circle, whether it be two tangents, a tangent and a secant, or two secants, if the intersection is outside, we have a different theorem for this. And in this case, the measure of angle X is going to be equal to 1/2 the difference of those two arcs. So we have a bigger arc AD and a smaller arc BD. So we would say the measure of arc AD minus the measure of arc BD. And I always remember this one because if it's outside, it's the big one minus the small one there. So in this case it would be 1/2, let's see, 178 minus 76. This gives us 1/2 of 102. And that gives us 51 degrees. Okay? So again, they're intersecting outside the circle, so we use the appropriate theorem and subtract these two. So that would give us 178 minus 76, and dividing by 2, we end up with 51 degrees. Now, for this next example, if you notice, we have an intersection outside the circle, and then we have two tangents here. Okay? And we want to know the measure of this arc BD. So this one's a little bit tricky. The first thing we need to do is we need to figure out, we know that CD and BC are equal, and we know that this is a tangent and a radius. Therefore, we can figure out what CD is or BC is, because those are equal. We can figure that out using Pythagorean theorem. And actually, I don't even know if we need that. Let me see. No, we don't even need that. But we do need to know what this angle is. Let's see. Actually, we don't even need to know that, because oh, we need to know what this angle is, because we want to compare it to this arc and that arc, and we want to know what arc BD is. So the first thing, if you notice, since this is a right triangle, directly opposite it is the 4,000, and the hypotenuse is 4150. So if we use SOHCAHTOA, we've got opposite over hypotenuse, so that would be sine of, we'll say, angle DCA is equal to the opposite, which is 4,000 over 4150. And I'm going to have to figure this one out. if we do that, then what we want to do is the inverse sine of 4,000 over 4150 is equal to the measure of angle DCA, which is this angle right here. And the answer is approximately 74.5. So therefore, since that's 74.5, we can state that this angle going across here is twice that. So it would be this angle, the measure of angle DCB. Oops, sorry. DCB is equal to approximately 149 degrees. Now, we want to know what arc BD is, where BD is from here to here. Okay? The reason why this one's a little bit tricky is because we don't know this and we don't know that arc. We know that the measure of angle DCB is equal to 1/2 this big arc right here, which is BED, minus the smaller arc, which is BD. The nice thing about this is those two angles together equal 360 degrees. So if I call arc BD X, I can call the other arc BED, I can call this one, which I'm going to mark with blue or purple, this one right here. If that's X, then this one is 360 minus X. So therefore, we know this is 149, and that's equal to 1/2. This is going to be 360 minus X minus X, where 360 minus X is BED and X is BD. Okay? And then it's just a matter of solving this. Got 149 is equal to 1/2 360 minus 2x. And since these are both even numbers, I'm going to go ahead and just multiply that out. We get 149 is equal to 180 minus x. We're going to subtract 180 from both sides. And if we do that, we get negative x is equal to negative 31. Dividing both sides by negative 1. X is equal to 31 degrees. Okay? A little bit of a tricky problem, I'll admit. So let's go over it again. So again, we know that there are right triangles formed by hypotenuse leg. They're congruent. So we know those angles are congruent, and we'd solve the right triangle. This is where I did that sine of angle BCA to get 74.5. So that whole angle is about 149. So we plug 149 in here, 360 minus x here, and x here. There it is. These combine to give me, well, they did all the work. Okay. So you get 31 degrees there. So that arc is 31 degrees. Okay? And we're going to find the value of this variable. Now this one's a little bit tricky because if you notice two things about it. First of all, they don't put the angle here. They put the angle here. So we know that these two angles or these two angles, those equal 180. So to find this angle right there, we do 180 minus 102. So this angle, which is the same as the other one, is 78 degrees. Now we know that 78 degrees is equal to 1/2 these two arcs added together. So it would be 1/2 y plus 95. If we do that, We really don't want to multiply the 1/2 out because this is odd and there's no number here. So I'm going to multiply both sides by 2. If we do that, 1/2 of 2 is 1. Over here we get 156, and here we get y plus 95. Subtracting 95 from both sides, we get y equals 61. So this arc right here, arc AB, ends up being 61 degrees. Okay. And here's another one where it's outside this time. And again, the angle isn't the variable here, but we know this is 44 degrees, and we know this is A, so we can say, we can say that 30 degrees, which is this angle, is 1/2 the difference of those two arcs. So FG minus KH. In this case, A minus 44. Again, don't want to deal with the half, so I'm going to go ahead and multiply by 2 right now. Half of 2 is 1. Over here we get 60, and we get A minus 44. Adding 44 to both sides. Those cancel, and A is equal to 104. So this arc right here ends up being 104 right there. And we're good. Here's another one, similar to the one with the Aurora Borealis or whatever. We know that, let's see, we know that this is 2, and we know that this is 3, so therefore this whole leg right here is 5, so QS is equal to 5. I want to know what this angle is here. So again, since I know that by hypotenuse leg this is 5 and that's 3 and that's 3, because they're both radiuses, I'm going to do sine again. So in this case, I want to know what this angle is. So angle TQS, and that's going to be opposite over hypotenuse, which is 3/5. So we're going to do the inverse sine of 3/5, and that equals the measure of angle TQS. I need a calculator for this. A sec. And we get approximately 36.9. We're going to have to multiply by 2 to find, we want to find the measure of angle TQR. This is going to be, 2 times 36.9, which ends up being approximately 73.7 degrees. So that's that angle right there is 73.7. So now, I don't know how I'm going to fit this in, but what I'm going to do is I'm going to actually call this X. That's fine. We'll call that X, and then this is 36 minus X, or 360 minus X. So we know that 73.7 is equal to 1/2. We're going to say X minus 360 minus X. Okay? So that gives us 73.7 equals 1/2, and this is going to end up being, because that's plus a negative and that becomes positive, this ends up becoming 2x minus 360. So multiplying that out, we get 73.7 is equal to x minus 180, and adding 180 to both sides, we get x is approximately 253.7, or about 253. Sorry about that. 253.7 degrees. So going back up to the top, that would be this arc right here. Okay? There we go, 253.7. And we're done. Thanks.